Now, LP modeling. There are different examples of LP modeling. There is transportation, multi-period, production, blending, investment, project selection, scheduling. They usually ask from those 5, maybe 4 of them. One of the ones that are very common is the investment. This is from the practice final. John has $300,000 to invest. For retirement, he has 3 options. Canadian equity gives the return 12%, US equity 9%, bonds give 7%. There are certain limitations. So we start the process the usual way. So I'm going to erase some of this. You need to define your variables. So we have Canadian equity, US equity, and bonds. So we say let CE be amount invested in Canadian equity. UE amount invested in US equity. And B the amount invested in bonds. You're maximizing return according to the question, and it's usually a max return question. You have the return of each one. This one, if you guys remember, 12%. This one is 9. This one is 7. So it's 12% of CE, 9% of UE, 7% of B. That's what you're trying to maximize. And then subject to. So now we start looking at the different constraints involved. One of them was in the very beginning of the question, the fact that this guy has $300,000 to invest and the 3 options. So I'm going to call this investment. So whatever he invests in CE, UE, and B is not to go over $300,000 because that's what he has available to invest. So now his investment is CEUEB. Now, the first point must have at least 20% of the investment of this, not this. This is not the investment. Your investment is whatever he decides to put in CEUEB. So at least 20% of them must be in US equity. At least 20% of this in US equity. You always start with N. So you have NUS equity, so that would be UE. What's in it must be at least 20% of the total investment, and as we said, your total investment will be CEUEB. And then again, at least 30% in Canadian. So in Canadian equity, you must have at least 30% of CEUEB. So we took care of the first 2. Must have at most 60% in both equities. So in both equities, we always start with what comes after the N, both equities. So what's in UE and CE must be at most 60% of the total investment, which is again CEUEB. Good. So they go to the next one now. He wants to invest at most $2 in Canadian equity for every $1 in bonds. Now, you will see this statement probably in the investment when they tell you you're going to do this for every this for every this. We call this the reverse statement. So anytime they tell you you're going to do this for every this, you start the same order. So they tell you Canadian, and then they say bonds. So they say Canadian equity, and then they say bonds. They say at most. This is what we use for at most. So we just keep the same order. They say Canadian, we put Canadian. Then they say bonds, we put the bonds. At most, we put the at most. The numbers, we switch. So they go 2 Canadian, 1 bond, 2 Canadian, 1 bond, but you switch the numbers, you put 2 and 1. Of course, you don't need to put the 1 here. So you could leave it like this, or just bring it back and say CE minus 2B less than or equal 0. You can put it this way. And then one more, at most 100,000 in bonds, so whatever you decide to do in B, not to go over 100,000, that's your limit for bonds. We took care of everything. There's nothing left. But again, when you do any LP modeling, remember, put this at the end. All variables must be greater than or equal 0. So put it at the end of any problem. There will be points on this, so remember you put it in all problems. Thank you.